Hello, my name is Brad Barker, and I'm a teacher at Georgia School for the Deaf. Today I'm here to talk to you about groundwater. So, during this video, a few things I want you to learn about. First off, I want you to learn about the interaction between surface water and groundwater. How does the surface water get into the ground? What are some of the different ways that happens? Secondly, I want you to understand the impact humans have on our groundwater. And third, how does groundwater move? And then how do things above the surface impact that below the surface? So now let's get started. Right here you can see I have what's called a Karst Groundwater model, and it's going to show us how two different types of groundwater function. This section over here is water that's in just like a normal area of ground, where under the ground there may be clay, sediment, maybe different types of rock. This type over here is called karst. The word karst means limestone. And the reason that's important is limestone areas, or karst areas, they tend to have caves, they tend to have very porous rock, and water moves through it very different. The first thing I want to talk about is how does groundwater get into the ground? So understand, a lot of the groundwater that's underground right now has been there for thousands and thousands of years. It didn't just rain yesterday and it's in our ground. It moves very slow. And how does it move? The way it moves is through little cracks and pores in the rock. We can also move through sediment like sand or dirt. Some areas the water can move really fast, and other areas it can move really slow. But what I'm going to show you now is this area right here. And to help you see how it's going to move, understand that this right here is like our recharge zone. So it's rained, the water's flowing down, and it enters into the ground here. And it flows through and goes out the other side of the model. To help you see what it looks like, I'm going to inject some red dye. So understand, red dye doesn't mean anything special. It's just there to help you understand how the water is moving. So now, I'm going to talk for just a second, but as I'm talking, I want you to focus on these three little areas of red. And what do they do? So now, a minute ago I was talking about the recharge zone. So understand that the recharge zone is related to watersheds. Whenever it rains, the water all flows from like the highest point towards the lowest point. So think about it like you have mountains in an area, and the water falls, and when it falls on that side of the mountain, it's going to flow down. It's going to start forming small creeks and streams, and then it's going to start to form larger streams to rivers. And so you can have small watersheds, and then a group of small watersheds together create a larger watershed. And then as the water's flowing, some of it's going to start to percolate into the ground or go into the ground. So when that happens, that's like this area right here. So now if you notice, the red color, it's not staying in the same spot. You may have noticed it's already starting to move. Okay? That's really important to know, because groundwater doesn't just stay in the same place. It starts to move. Gravity has an impact on it, just like it does on us. So now, I want to talk about how we as humans can impact the water, because we use a lot of water. Alright, so as you can see, the red color has now started to move. And the way that this is moving is really important, because it shows us that groundwater actually doesn't stay in the same place. It starts to show the movement, the direction the water's going to flow, which gravity has an impact, and it moves it in a downward motion. And you can see that here. Understand, here it looks a little bit weird. Why is that? Our water table is right around here, and that's the point of saturation, where it's completely full of water. And so if you notice, it's kind of going back up, and it's following along the top of the water table. So now, I've added something here, because at my house where I live, I have a well. And many people get water from wells. And what that means is they've drilled a hole into the ground, and then they pump water out of the ground to use in their house. Some areas of the country, cities use wells, or maybe counties use wells, to get water for the people that live there. But it also can be just people who live in their house by themselves. So how does that impact our water supply? Let's take a look. So right now, all I'm doing is I'm pumping the water out through my well. And I want you to look at the colors on the model. If you notice, look at this red. All of a sudden it's gone straight to my well. start to notice these colors here as well. Instead of trending this direction now suddenly, take a look and notice what they're doing. Which way do you think they're going? If you guessed this way, you were right. They're going straight down. So remember, the red is just to show us how the water is moving. It's to help you see the direction the water is going. But I also want you to notice something. Over here, used to I had water in this sinkhole, but now the water table is way down here. So I hope that you understand, when I'm using my well, I'm lowering the water table in my area. Because I have this area, you can see it a little bit easier than normal. But typically what it does is it'll make a cone down to the area where it's being pumped, because water can't fill that area back in as fast as I'm taking it out. So that means when I'm taking a long shower, or when I'm washing a half-empty load of dishes in the dishwasher, maybe I've washed my car every weekend, each of those things has a direct impact on our water supply. And if we're not using the water carefully, then we can deplete a water source. Over time, you'll notice it does come back up. But remember, this is a really small model. I'm giving it a constant source of water. So if you're in a drought, you're not going to have this much water coming back this fast. Alright, another thing I want to talk about is my house. I have a septic tank. So that when I flush the toilet, it goes into this big tank that then starts to go out into my yard. And the way that that works is bacteria eats up all of the bad stuff so that it doesn't hurt my water. So my well and my septic tank can be fairly close and it doesn't bother me because the bacteria take care of it. But sometimes something bad can happen, and maybe I have a crack in my septic tank. So the green color that I'm going to introduce is going to represent pollution. Now, it doesn't just have to be from my septic tank. Maybe there's a gas station and the gas station has a leak in their gas tank. Or maybe it's a spill from a tanker truck driving down the road that's full of chemicals. But I want you to watch this green color. I've put it in and there's a leak. There's something happening underground. So as I'm doing this, I want you to watch, how does the green move? Does it move the same as the red color did, showing us the groundwater movement? Does it move different? So pay attention to that. So right now, I don't know if you're noticing, but I can see green all the way over to there. But one of the things I want to talk about is the green color. Notice that as it's moving, it's not moving as this huge, big, dark blob the entire way across. It starts off really dark, and then it starts to get a little bit lighter. That's really important to notice, because in this type of ground, where there's sand or there's dirt, the particles kind of filter out the pollution a little bit. It's still not good, but it means that you're not going to get the full blast of the pollution all at one time. Alright, so I'm going to do a lot of pumping here because I'm really thirsty, or I like to take really long showers, or maybe I'm taking care of a whole city and there's more people there than I have water for, so it means I'm constantly pulling water out. Alright, take a look at the green color again. What's happened to it? So it started here. I'm going to use the story about my septic tank. So my septic tank's got that leak, and I'm drinking the water out of this well. And now all of a sudden you're noticing it's making this trend. Now, it's not been super duper fast. I'm kind of speeding things up here. It takes a little bit of time to get there, but right now the green is just getting to my well. Alright, I now have green color coming out. So my water supply has now been polluted. So if I didn't know that this had happened, then I've got a big problem, because here's the pollution and it's coming into my drinking water. It's coming into the water I'm bathing with. How can I get clean if this water is full of my poop? That's not going to happen. So now that you kind of understand how this works, how do you think that people can impact the water supply? It's a really good question. And so what I'm going to do is I'm going to let you post comments below this video, and I want you to tell me how you think people impact our water supply. How do things that we do show up? So now I'm going to kind of speed things up just a little bit, And I'm going to give a big rain shower over here in this area so that I can fill it back up from where I've drained it. So I live in an area of limestone, a karst region of the United States. That's areas in the location I'm talking about, where I live, Tennessee, Alabama, and Georgia. There are huge areas of those states that have karst. Millions of people live on top of it. And I worked with an organization called the Sierra Karst Task Force. It's a part of the National Speleological Society, and we would do cleanups. And what would we go clean up? We clean up trash that people would put into sinkholes. So what happens is the ground is a straight line, and a sinkhole forms when all of a sudden there's nothing to support the surface anymore because all of these caverns and cavities have opened up, and so it falls in. Well, people see that, and sometimes maybe it's in the middle of their yard, or maybe it's next to their property, and they're like, well, where'd that hole come from? And they want to fill it in because they don't like it there. So they start to put their trash in it. They need to put it somewhere. So they start piling trash into it, and they hope to fill it up. Well, the group I worked with, we would come in and clean that trash out and try to restore it to the way it should be, because a lot of the people didn't understand their impact on their water. So that's what I want to show you now. So I'm going to take some more pollution, and I'm going to put it in right here. So my sinkhole is now got polluted water in it. And notice, already, that pollution is in my water. I don't know if you can see it really clearly, but the green is just now starting to come down. Well, if I live in this area and I need water, I have a well again. So what happens when I start to use my well? Well, I'm going to pump. I hope you can see this green color because it's immediately starting to spread. Alright, I already have green. So I already have pollution coming into my water. You remember over here, it took me a lot of pumping, a lot of waiting before it got there. But on this side, I did like 3 pumps. So I used my well for just a couple of minutes, and already this pollution has showed up over here in my well. So this is really important to understand. This area, the ground does some of the filtering for us. But over here, the water that comes in right here, very quickly is flowing throughout this entire area. There's no filtration for it. And what happens is when I start to use the water in that area, I get polluted water really quick. But also understand, it could be other things. If you live in a karst region and just having cars driving down the road that drip oil, when it rains, that flows off of the roads and it gives us non-point source pollution. And so what that means is the surface pollution, non-point source pollution, all these different sources, all of that adds contamination. Point source pollution, I want to tell you what that means real quick. Point source is like a specific thing. Remember I talked about the tanker truck that maybe it flipped over and it spilled and they didn't get it all cleaned up? That would be considered point source solution. It comes from one source. So I hope that you've learned a few things from today. A couple of things I want to remind you about. First off, how does surface water and groundwater interact? Remember, surface water, it rains, it falls down, it hits the ground, and it goes into recharge zones. Recharge zones flow through underground. Some of the water stays on the surface. That's our rivers. You know, the Mississippi River watershed, it's a really big watershed. It covers most of the United States. That's all surface water. But if it enters a recharge zone and it goes into our aquifers, it goes into our underground groundwater supplies, that's how it gets in. Another thing, how fast does groundwater move? Remember, groundwater moves really slow. It's not fast. It can take thousands of years for it to move just a short distance. So our impact on that, if we start pumping out a lot of water, do you remember my water table dropped? So my use of water has a huge impact on the water table and on the water supply for my area. But if you're in this area, a karst region, an area with limestone under the ground, remember it has a huge impact really fast. Water in these areas moves really fast. In fact, I'm a caver, so if I go into some of the caves that I like, a couple of them, if it's going to rain, I'm going to be underground. I can not even know it's raining outside, and the cave can flood shut within just a couple of hours. That's how fast water can get into areas like this and enter into groundwater. So, in the comments below, I want you to tell me, what did you think about the video? What are some things that you learned? Also, I really want to know your answers to the question, how do humans impact the water supply? And lastly, if you have any questions, please leave them in the comments below, and I will be glad to send you an answer. Alright, thanks for watching. Take care.